Okay, so I know a lot of people struggle with the graphs associated with batching. And I want you just to recognize that these are just inventory graphs um, that you've done in BDM before. Okay. And so when we're thinking about the inventory graph, we just want to make sure we understand our axes here, where along our x-axis we have time. And then along our y-axis is the count of our inventory. And so you will see a lot of graphs that look like this. This is like the classic batching graph. Um, and you do want to make sure that you are comfortable graphing these graphs, not just because of the exam, but because it can also be quite helpful in just understanding the concept of why we do batching problems or flow interruption problems the way that you do. Okay. So, just for an example, I'm going to start with, let's say that we can produce at a rate of 100 units per hour. Okay. But demand is 40 units per hour. So, what happens if we produce for 10 hours? Okay. Well, we want to recognize that each hour, right? Yes, we produce 100, but we are selling 40. But what this tells us is that our rate of increase of our inventory is going to be 60 units every hour because we're going to produce 100, we're going to sell 40. So we are going to increase our inventory by 60 units per hour. So if I produce for 10 hours, after hour one, I would have produced 100 and sold 40. I would be at 60. Then after hour two, I would have added another 60. Three, my inventory is going up again. I'm going to be at 180. This is not to scale, but thankfully I have the magic of a whiteboard where I can keep going up. So after 10 hours, though, what we know is that our inventory would be at 600 units, right? Now, the whole point of batching or flow interruption is that we stop producing for a while. And so if I produce 100 and I consume or demand consumes 40 every hour, after 10 hours, I've got 600 units in inventory. But remember, demand is 40 per hour. So if I stop producing, how long is it going to take me to use up those 600 units? Well, I can take 600 units and I could divide by my demand, which is 40 units per hour. Units and units are going to cancel out. Hour is going to end up on top, and I'm going to end up with 15 hours. You can also test that. If I have 40 units and I allow demand to continue on for 15 hours, it's going to use up 600 units. And so what we've actually done here is we've decided that if we were to run our process for 10 hours, then we would need to not run our process for 15 hours in order to come back down to zero. So if we think about this inventory graph on a bigger scale, we know that after 10 hours, because we are increasing at that rate of P minus D, production minus demand, 100 minus 40, which means 60 per hour. We then stop producing. So this is while we're producing. And we're going to stop producing for 15 hours because we're going to use this up at a rate of 40 per hour, right? We go down at that rate of whatever our demand is. And that brings us to 25 hours. Okay. And then this repeats. We produce for 10 more hours. So it's going to bring us to 35. And then we don't produce for the next 15 hours, and that'll bring us to hour 50. And so this is what we're talking about when we're talking about batching. And when we're figuring out the ideal batch size, right? What we're actually trying to do for the ideal batch size is determine the number of units to produce so that in the cycle of producing and not producing, our inventory comes back to zero before we produce the next time. So in this situation, I specified it by time, just because I'm trying to just think about this a little bit differently, give you a different perspective to think about it if it hasn't sunk in right away for you. Right? Where I just told you, hey, you're producing for 10 hours. Now, one of the things to recognize is how many units did you actually produce? Well, in this situation, that batch size, I'm running production for 10 hours and I can produce 100 units per hour. So when we talk about batch size, we're talking about it in this way where I'm like, hey, it's actually 1,000 units for this batch size. We don't approach it typically not in this way. We're not given the times. We're given individual times, and then we have to figure out what's going on from there. But I just want you to understand conceptually what we're trying to do is we're trying to get that inventory back down to zero before we produce again. And you can do the batch sizing questions, you can do the graphing questions. If you're really struggling though to graph the answer, it really comes from practice. Okay? So I would encourage you to ask yourself, well, what happens? What if we produce at a rate of 8 per day? Demand is 2 per day. And our batch size is 16. And then I ask you the question of how long between batches? You're not going to have a question like this on the exam. Okay, that's not what this is about. This is just about like testing our understanding, right? That we know if we're producing at 8 per day and the batch size is 16, this tells us that we are producing for 2 days. We know that for each of those 2 days, we are going to be putting 6 units in inventory because the difference between production and demand is 6. So after day 1, we would have 6 units. After day 2, we would have 12 units. How long is it between batches? Well, we only want to start the next batch once our inventory returns to 0. So we are producing for 2 days, but then how long are we not producing for? Well, that question is, how long does it take us to use up 12 units in inventory? Well, if our demand is 2 per day, that is going to be 6 days. So that is 6 additional days, which brings us to 8, right? We're going to be decreasing by that rate of demand, so down by 2 per day. Here we are going up by 6 per day. And what this tells us is that our cycle time is 8, right? There's going to be 8 days between those batches. But then what happens? Draw the graph for 3 cycles if the time between batches is 6 days. So what happens? Well, our production and our demand doesn't change. We're going to have 3 cycles though, so it's going to be longer. Day 1, we're going to add 6 units to inventory. Over day 2, we're going to end up at that 12. But now there's only 6 days between runs. So instead of getting all the way to 8, our cycle is only going to get us to 6. And while we increase at that rate of production minus demand. So in this case, 6 per day. We decrease at a rate of 2 per day because that's our demand. So we're going to go down. Oops. So we have 4 days here. We are going to go down by 8. 12 minus 8. I'm still going to have 4 units left in inventory on day 6. Then what happens? Well, we start production again. We're going to increase by 12. Except we didn't start at 0, we started at 4. So by the end of day 8, our inventory is 16. For 4 more days, we're going to go down by 8 because we're going to use those 4 up. We're going to use the 4 days worth of inventory up. This is not a great graph, but, and we're now going to have 8 units left in inventory. And it continues on. And then we go back down. And the point here, we're at 12 units left in inventory, is that because we are not coming back to 0 between running our batches, every time we run a cycle, our inventory goes up, and our inventory is going to increase by 4 units per cycle.